I've always had an interest in the design and construction of motor vessels that can go fast at sea. This kind of work is immensely interesting. 12-metre yachts are lots of fun and lots of trouble as well. And I suppose to a lot of people it must look like a very glamorous form of naval architecture. This, to me, is probably one of the most interesting vessels that we've ever had to work on. And I find the problems associated with this sort of design at least as interesting as the problems associated with 12-metre yacht design, and the end result is something which is every bit as satisfying to me as a 12-metre yacht. It does require a very robust sort of vessel which can be put to a lot of hard usage, but which at the same time can go fairly fast. So we had to devise a means of building a very light structure, and this is where the use of aluminium was decided on. The first aluminium boat of any size was built over 30 years ago and is still operating in England and is in very good structural condition. All of the aluminium companies have been working on a whole range of very desirable aluminium alloys which have high strength, high corrosion resistance and light weight. And we now have available to us very suitable materials for this sort of boat construction. They are used as patrol craft in Vietnam by the Vietnam Police, by the United States Navy. They are used for supplying offshore oil rigs with crew and with perishable cargoes. They are used for Air Force crash boats, for police launches, for customs launches. In fact, the variety of uses is almost limitless. Anywhere where you need to travel reasonably fast at sea at moderate expense, this sort of vessel is very useful. One of the most difficult requirements to comply with for this particular vessel was the draft restriction. The draft can't be more than 3 feet when the vessel is fully loaded. So we managed, after a lot of modification work, to produce a recess called a tunnel in the bottom of the hull over the top of each propeller, which permits us to get in a rather larger propeller than we would have had otherwise, and increases the propeller efficiency because each propeller is absorbing 350 horsepower. Immediately in front of each propeller are these skegs which carry the stern tubes through which the propeller shafts pass. They carry the bottom rudder bearing on each side, and they also permit the vessel to sit upright on the bottom. These propellers have high-strength stainless steel propeller shafts, and in order to avoid electrical connection between the bronze propeller and the aluminium hull, we have used plastic bearings in the stern tubes and flexible couplings which have complete rubber insulation of the propeller shaft and propeller from the rest of the machinery and consequently from the hull. The idea of building a prototype work launch was put to the Industrial Research and Development Grants Board, and it has been adopted as a suitable project. This hull is a very big one. It's 50 feet long, and it was essential to save a lot of weight in that. If it had been built of steel, it would have weighed about 13 tons. As it is, it's very strongly built out of a marine aluminium alloy, and there is a little less than 6 tons of aluminium in the whole boat. This includes the superstructure, all the bulkheads, and the large amount of heavy framework which is inside. The engine beds are very massive to enable engines of much higher horsepower to be fitted if necessary, if we decide that in later versions we need additional speed. A number of the requirements conflict with each other. For instance, the vessel may sometimes have to act as a small tugboat towing barges at perhaps about 6 knots speed. At the other end of the scale, it has to be capable of a fairly high top speed of about 20 knots. A lot of horsepower in these two engines, and they need to be in a place where they can be well ventilated and properly maintained. By putting them in the stern, we got them right away from everything else, and this will also help the noise level in the crew accommodation and in the navigating bridge towards the bow. Now, the engines are flexibly mounted to transmit the minimum amount of vibration to the structure. This will help from the fatigue point of view and also from the noise level and vibration point of view. The main cargo hold is immediately forward of the engine room. There's a large amount of space in here. It will carry about 20 fully equipped soldiers, or 8,000 or 9,000 pounds weight of cargo, bulky objects. The aluminium alloy used in the construction of this boat has approximately 4.5% magnesium content. This produces an aluminium which is exceptionally resistant to saltwater corrosion. It is nonetheless very strong and is easy to fabricate. This vessel is designed for a wide range of operational areas. It has to be capable of high speed in shallow rivers as a harbour craft, and out at sea under conditions of fairly bad weather and big waves.